Woo! All right. Let's go, people. Hey, if you're not subscribed, please do so. Throw a like, tell your friends, tell everybody. Hey, go ahead and download a free PDF file in the description. It's in English y Espanol. Perform the problems, come on back, hang out with me and see how it's done. All right, here we go. This is Algebra 1, writing functions using rate and initial value. Practice worksheet. Our friend Roman bought a goldfish for 50 cents at the Fish for Math fish store. The goldfish was initially 2 inches long. Ooh, that's important information. The initial value, right? Initial value, that's our y-intercept, or our initial value. The goldfish grew at an average rate of 1/3 of an inch per week. Ooh, that's important information. That is my rate of change. I change at 1/3 of an inch per 1 week. So that's how we change in the length. Create a function LW where W is the input value. All right. W is the input. I'm going to mark that. That means weeks since Roman bought her goldfish. And LW is the output. Ooh, that's the length of the goldfish after W weeks. All right, let's do it. Assign variables. Well, they kind of already did. The output, length based on weeks, is equal to the length of the fish. The W, which is the input variable, is the weeks. All right, let's do it. What is the initial amount? The constant term. Well, that's right there. The initial amount is 2 inches. So I'm going to put 2 inches. Identify the rate of change. Well, that's right there. The rate of change is 1/3 of an inch per week. So 1/3 of an inch per week. And you should write all of this. Unit of measurement. There's a couple different ways to write that. So just make sure you write it the way you want, but make sure it's correct. Create a function LW. Okay, so my output is the length with input W. This whole thing represents the output. Now, I have a rate of change of 1/3 times the input variable, W, plus the initial value. Boom, that's it. We're going to base everything on that now. I'm going to grab my calculadora because now we're going to create a table of values. Oh, this is more important information. This model is only valid for the first 32 weeks. So after 32 weeks, this model is no longer valid. Then the fish either grows at a different rate or, fish passed away. I don't know. I just don't know. Okay, so we're going to make a table of values. They want us to use 5 inputs and 5 outputs, including the minimum in a word problem with time. In mathematics, the minimum is almost always 0. And the maximum is going to be that value they gave me here. The model is only valid for 32 weeks. That's the maximum. All right, now I'm just going to include 2 other ordered pairs. I'm going to do 10 and 30. There we go. So there's 1, 2, 3, 4, 5. It's 5 inputs. Now I got to find the output. Hey, I can do this one. When I know the day that Roman bought the goldfish, that's time 0. That's the initial length. So that's 2 inches. All right, now I'm going to go to my calculator, and I'm going to put these in. Notice they want us to round to the nearest 10. All right, so let's do it. I'm going to go up here a little bit so we can see that. Okay, so I'm going to put in a value of 10. So 1 divided by 3, that's what a fraction bar means. Input 10 plus 2. 5.3. Man, that goldfish is growing fast. Now I'm going to do the same thing, but now I'm going to change my input. Now I want to know how long is the goldfish after 20 weeks. Plus 2. 8.7 if I round that correctly. Right? Because if I'm rounding to the 10th, which is right here, if this is a 5 or more, I add 1 to that. If it's a 3 or less, it's a 4 or less, I just leave it alone. All right, now we're going to put in 30. 1 divided by 3 times 30 plus dose, 12 inches. This goldfish is huge. And then I'm going to do the last one. And that's enter 32 weeks plus 2. 12.7. My goodness. That must be a big tank. All right, all right. Now all of these represent ordered pairs, right? X comma Y. So this is an ordered pair. This is an ordered pair. And dot, 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 dot. This is an ordered pair. So all of these are ordered pairs. All right, that's a 12.7. That's a lousy 12.7, but that's what it, oh, that's not any better. That ain't no better. All right, so let's plot some points. 0, 2. I got that. That's money. 0, 2 right here. All right, now I'm going to go to 10, 5.3. 10, 5.3 is a little bit more than halfway between 4 and 6. So I'm going to go about there, just approximating. 28.7, that's a little below 9, right? It's a little below 9, right about there. 30, 12. Oh, that lands right on there. I like that. I like that. And then 32 is a little less than halfway between 30 and 35. And 12.7, I'm going to say right about there. Notice how all of those line up nicely, right? If they don't line up, you made a mistake because this is a linear equation. That means the pattern that the solutions make is a line. All right, now because things are approximated, there's a chance we're a little off on some of these, but it looks pretty good, pretty good. Notice how I do not drive it through the minimum and maximum, right? Because the model is only good from 0 to 32 weeks. So before 0, this model doesn't make sense. After 0, after 32, this model is no longer valid. Okay, okay. That's our graph. Identify the minimum and maximum output values. Well, the output is length. So the minimum output value is 2 inches. Please put unit of measurement on that. The maximum was 12.7 inches. Okay. How many weeks did it take for the goldfish to reach a length of 10 inches? Oh, okay, okay. So notice what they're saying here. How many weeks? So that's W. And then they say length of 10 inches. That's LW. Okay, so I'm going to go to my model, and I'm going to input a value for LW. Not for W, for LW. So here's what that looks like. Did I miss one? I did miss one. I'm going to go back up to H real quick. I'm sorry. So 17 weeks. That means I'm going to my model. And I'm going to go ahead and input 17 for weeks, right? See how it says how long? So that means I'm looking for this. How long? So L of 17, the length at week 17 is 1/3 times 17 plus 2. Calculator. That's 1 divided by 3. And that's 7.7. Don't forget your unit of measurement. 7.7 inches. My paper's moving around here. Okay, 7.7 inches. Now we're going to go back to this one. Okay, so notice we're looking for LW, right? We're looking for weeks. We know a value for LW. Here's my model. My value for LW is 10. That's the length. And what I'm looking for is W. So I want to solve this equation for W. I'm going to go ahead and inverse operation. The inverse operation for plus 2 is a minus 2. So I'm going to subtract 2. Boom. Subtract 2. Let's go ahead and rewrite it. 8 equals 1/3 W. Now I'm going to divide by the 1/3. Remember, when you divide by a fraction, you need to put that in parentheses so the calculator does the order of operations correctly. I want it to simplify the 1/3 before I divide 8 by it. So I'm going to do 8 divided by, in parentheses, 24. So it's going to take 24 weeks to get to 10 inches. 24 weeks. Now I can look and see how accurate that is. So watch what I'm going to do. I'm going to go here to 10 inches, right there. And notice 10 inches is right here on the graph, right? Because I just follow it straight over. So I just follow it straight over. Ooh, that highlighter's not working so good, but that's all right. We'll make it work. And right there is where I hit the graph. And then you come straight down. Look at that. That is 24, right? So that works. I love that. That's what I love about graphs, is you can kind of look and see if it makes sense. Okay. Is this graph increasing, decreasing, or both? Well, notice you read increasing and decreasing from left to right, just like reading a sentence. So, notice we're going up, 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 up. So it's increasing the entire way. Increasing. All right. Let's do problem number 2. Good job. Okay. On old Carl's farm, okay, there is a water storage tank. The tank holds 8,000 gallons of water. Okay, that's important because that is the initial amount. Okay, Carl's on vacation and the tank sprung a leak. Oh no, Carl. The tank leaks water at an average rate. Ooh, that's important information. There's that word average rate. So it's the tank leaks water at an average rate of 5 gallons per minute. So we're measuring gallons in minutes. Do you remember when we found the slope change in y over change in x? So the y is gallons and the x is minutes, right? Change in y over change in x. That's what that means. So we're going to create a function, g of m, where m is the input value, okay? So m is the input value right there. That means the number of minutes the water's been leaking, and g of m is the output. All right. And that represents gallons of water left in the tank after m minutes. Okay, let's do this. Assign a variable. All right, so I'm going to do my input variable first. That's m. That's minutes leaking. Okay, and then I'm going to do g of m. And that's gallons left. All right, good job. What is the initial amount? Well, that's how many gallons are in the tank. Make sure you do units of measurement, please. The rate of change. Okay, now this is important. Remember with the goldfish was getting longer. So my rate of change was increasing. Here, we sprang a leak. So ask yourself the question, is the initial amount getting smaller or is it getting larger? Right, it's getting smaller. So your rate of change is negative 5 gallons per, you can do a fraction bar as per 1 minute. All right, let's create a model. G of m. G of m equals your rate of change times your input plus the initial amount. All right, there's the model. Okay, now we're going to create a table of values. Let's do it. Notice when we create a table of values, we have to use 5 inputs and 5 outputs and include the min and max. Okay, so we're talking about time. So there's min. The max, well, we don't know the max time. We don't know the max time, but what do we know? We know if the tank has not been leaking at all, there's 8,000 gallons left, right? That's what we know, right? So times 0 means we haven't sprung a leak yet. But now, boom, we leak. Well, how many minutes does it take to what? For the tank to empty, to get to 0 gallons. So I know that is also true. Okay, so I got to calculate this. So what I'm going to do is I'm going to go to my model right here. G of M equals negative 5M plus 8,000. And what I'm doing is I'm going to find my max minutes. That's what I'm doing. I'm finding my max minutes. How long does it take for the tank to completely empty? So what I'm going to do is I'm going to put in what I know. And I know at max minutes, which is right here, there's 0 gallons left. This represents gallons. So there's 0 gallons left. And I'm going to solve this for M, and that'll tell me how long it took for this tank to empty. I'm going to subtract 8,000 from both sides. Ooh, you know what? You could actually add 5M to both sides if you want. That would be cool. That would be cool, but I'm going to keep going this way. But honestly, if I had to do it all over again, I think I might change my mind. So that's negative 8,000 equals negative 5M, because I like to put my variables on the left. That's why. Now I'm going to undo multiplying by negative 5. That's dividing by negative 5. So I'm going to do 8,000, negative 8,000. Turn that on. Negative 8,000 divided by negative 5. 1,600 minutes. That's how long it's going to take. Oh, that's how long it's going to take for this tank to empty. So this max time is 1,600. Okay. Now I'm sorry they put that 20 in there. I think I'm going to change that to a 200. All right. And I'm going to go ahead and do I'm going to make that first second. I'm going to do 800. And I'm going to do 1,200. Okay, so I'm going to do those. 1, 2, 3, 4, 5 values. Okay, so let's go ahead and make a table. Let's do it. So I'm going to do negative 5 times the input. The input is 200 plus 8,000. 7,000. Okay. So after 200 minutes, there's 7,000 gallons left. Now let's put in 800. Well, that's half the time. I think there's going to be 4,000 gallons left here if everything works out. Yep, there it is. Because that's half the time it took to empty. So 4,000. And then I'm going to put in 1,200, which is 1,200 plus 8,000. That's 2,000. Remember, this is how many gallons are left, right? We've been leaking for this many minutes. This is how many gallons are left. All right, now we got to create a table of values. So we got to come up with our own X and Y axis, and then we have to plot points. Okay, so I know my input, M, is minutes. And I know my output is G of M. I'm going to do a capital G of M. And that's gallons. Okay. Gallons of water if you want. All right, now we got to come up with increments. So this is where you really got to think. I like to get like somewhere between 10 and 15 increments. That really is my goal. So you get somewhere between 10 and 15 increments. So I'm going to take 8,000 to 0, and I'm going to do increments of 500. Now I know that's going to give me 16. Let's see, will that even work? So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, 16 will work. All right, so I'm going to do increments of 500 gallons. Sorry. Dang it, these are minutes. I'm going to do increments of 100 minutes. Here, I'm going to do increments of 500 gallons. All right? Increments can be different on the X and Y axis, but they have to stay the same on the axis. So start at 0, 1, 2, 3, 4, 5. So that's 500 right there. 1, 2, 3, 4, 5. That's 1,000 right there. 1, 2, 3, 4, 5, 6. I'm just going to go to 16 right there. Okay, now I'm going to go, because that's my maximum, right? So I've hit my maximum on my axis. And see how I'm using the majority of my axis? That's nice as well. So I'm going to go 0 again, 501, 502. I'm going to go 2,000 right there. 2, 3, 4, so 4,000. 5, 6, 6,000. And 8,000. So I've got my max input and output on both axes. Now I'm going to graph it. So I'm going to plot points 0, 8,000 right there. 200 is right here. 7,000 right there. Okay. Now I'm going to do 800, which is right here, and 4,000 right about there. This should all line up nicely. 1,200 and 2. And then the last one is going to be when the tank is empty, and that's 16. Look at how those line up nicely, right? That's sweet. Oh, look at that. That's beautiful. That's the way it should be. That's the way it should be. Now, time is continuous, so I got to think about that as I'm graphing it. Okay? So this is a continuous function, so I'm going to go ahead and connect everything, because every fractional input and output is valid between the minimum and maximum point. So that's important. Make sure it's continuous if it's continuous, showing on the graph. All right, identify the minimum and maximum output values. Well, the output is gallons, so the minimum is 0 gallons. The maximum is 8,000 gallons. How many minutes did it take? All right, so again, we got to think about what they're asking. How many minutes did it take the tank to have a total of 2,500 gallons left? Okay, so I'm going to go to my model, and I'm going to do this. So I'm going to go to my model, and I'm going to go to my output, because the output is gallons, and solve it for the input. So, remember, this is my output, so I'm going to let that be 2,500, and solve it for the input, minutes. How many minutes? You got to read these questions and help that guide you. Okay, inverse operations. Oh, I forgot a 0. I'm going to subtract 8,000 and subtract 8,000. I'm solving the equation. This is why you need to know how to solve equations, because you can't do higher level thinking if you can't. This is negative 5,500 is equal to negative 5m. Now the inverse operation of multiplication is division, because this is multiplication between the negative 5 and the m. And you're going to get a whole lot of positive. It's got to be positive, because time can't be negative in this case. 1,100 minutes. Now, I'm curious to see how accurate this is. So I'm going to go to 2,500. So I'm going to go right here on the graph to 2,500 gallons. So that would be right here. And I'm going to follow it over and then follow it down. Oh my gosh, look at that right there. It's spot on. Oh, you can't see it. Dang it. Okay, so I followed it over from 2,500. Remember, these are increments of 500, so 25 is right there. Hit the graph, because this is on the graph where the y value is 2,500, is straight across. Now you come straight down, and that's the x value, the input, minutes. And look at how it's 1,100. Right what we said. A go. Okay, how much water is left in the tank after 12 hours? Whoa, what's going on here? We're not measuring in hours. We're measuring in minutes. So I got to convert these hours to minutes. So I'm going to. How many minutes are in an hour? 60. That right. So I'm going to do 12 times 60. That's the same as 720 minutes. Okay, so I'm going to go to my function. I'm going to go down here. And I'm going to say g of 720. Because now I'm going to find the number of gallons with an input of 720 is negative 5 times 720 plus 8,000. Put that in your calculator. Negative 5 times 720 plus 8,000. 4,400. So the number of gallons left after 720 minutes is 4,400. And don't forget your unit of measurement on these ones. Is this graph continuous or non-continuous? Well, heck, they should ask that question way up there. This is continuous because time is continuous. You can be leaking water for a second, for a half a second, for a minute, for 3 minutes, for 3 minutes and 40 seconds. So at a time between 0 and 1600 is valid. All right. I'm going to create a new video for problem 3 and 4. All right? So I'm going to stop this one, and then I'm going to create a new one. Okay. Nice job, everybody. Nice job. Stay strong. Don't let your distractions get in the way of your success. Don't forget to like. Don't forget to subscribe.